Hello, I'm Jared Ferguson, and today I'm going to talk to you about how crust accreted to a continent that would eventually become North America to create the basement rock of the Southwest. So to help us understand this process, I've created the following cross-section of the Earth. So it has two parts. Here's the first part of the cross-section, and then here is the second part of the cross-section. So let's go ahead and take a look at the different components of the cross-section. So the terracotta color of this cross-section represents the asthenosphere. The asthenosphere is found in the upper mantle portion of the Earth. It is a semi-fluid layer that is mechanically weak and deforms easily under stress and tension. So its composition is much like that of taffy. It's a very soft rock that's malleable and bendable. So let's go ahead and take a look at the next portion of my model. So the next portion of my model is the lithosphere. The lithosphere includes the upper mantle, which is represented by brown in my model, as well as the continental crust, which is represented by green in my model. So the lithosphere is the outermost shell of the Earth. It is a rigid and brittle layer, so its composition is very hard rock. The continental crust is where you would find the vegetative color, the volcanoes, the mountains, the hills, the trees. And then the final portion of my model is the oceanic crust. So interestingly, the overall paradigm for which to understand crustal accretion in the Southwest came about when geologists began studying Cenozoic and Mesozoic rocks. During the late 70s, many geologists also noticed that much of the western United States contained blocks of rocks that did not form in continuity with their adjacent surroundings. Or in other words, when these blocks of rocks were forming, they weren't touching their surrounding rocks or the surrounding rocks. And so these blocks of rocks were known as exotic terrains. And what this suggested is that the crust of the Southwest was formed in a distant location and then carried to its present-day location by the means of tectonics. And so the mode by which the crust of the Southwest was carried to its present-day location was through a subduction zone at a convergent boundary. So let's go ahead and get a little bit more comfortable with subduction before we go on. So subduction is when you will have two continental plates. They'll be moving toward each other, and then one of the plates, due to the density and the thickness of the two plates, will subduct under the mantle. And so that the plate that is thinner and more dense, such as the oceanic plate, which is thinner and more dense than the continental crust, will subduct under the continental crust and into the underlying mantle. So most often in subduction, volcanoes will form on the overriding plate. So if the overriding plate is continental, let's go ahead and take these island arcs off here. If the overriding plate is continental, then you'll have volcanoes form a lofty volcanic mountain range, such as this volcano right here. So an example of this would be the Andes in South America. If the overriding plate is continental, then you'll have the volcanoes form an island arc. So here's an example of where the overriding plate was oceanic and you had islands formed due to the volcanoes. So the magma that comes and forms these volcanoes originates from two sources. The first source is the overriding mantle, which partially melts and is fluxed by the fluids from the subducting slab. The second source, and let's go ahead and show you this, is the subducting slab itself if it gets hot enough. And so let's go ahead and set up our island arcs here. So in subduction, what'll happen is these island arcs will get carried on the back of the subducting plate, and eventually, as they are carried on the back of it, they will collide with the continental crust, and with geologic time, they'll be sutured to it. So let's go ahead and give you a demonstration of this. We'll do one or two depending on how well the first one goes, to give you a very good idea of exactly how did the crust accrete to this continent that would eventually become North America to form the crust of the Southwest. So let's go ahead and get our model all set up here. Make sure we get a great one going so we can get a very good demonstration of all this happened. And so we'll go ahead and put this. So we notice our island arcs right here. And so as this plate begins subducting under the underlying mantle, you'll see that my island arcs begin colliding with the continental crust, and you can see my plate going down and beneath the continental crust and into the mantle. And so let's go ahead and do one more just to get a nice firm idea of what's all happening here. So let's go ahead and set the model up once more. So once again, we'll have our island arc. And so once again, the subducting slab will go right under in here. And as you can see, my island arcs are beginning to collide with the continental crust, and eventually they'll suture right to it. Thank you.